So, hello everyone. Should be live here now with Craig Williams here from what is it? The Neutron Engines that you're working on the V8 K24 uh, sort of a version or modification, something like that. And oh, I need to get his picture up here also. So let me just add in an image. Yeah, this is like genuine live stuff here, so bear with us, guys. And browse for that image. Picture right here. And then let's get him on board here also. So let's just put him over here maybe.
I'm good to go.
Okay, nice. Let's see. I can hear you pretty good, I guess. Could you, yeah, introduce yourself maybe a little bit shortly, and I'll adjust the volume here as we go at the same time.
Yeah,
Could you
no problem. My name's Craig Williams. I'm a mechanical engineer. I'm based over here in the United States. Uh,
Okay, let's. I think we'll need to bump up your volume quite a lot here so that people can hear you. Let's see if that maybe works better. Okay. Um, so yeah, I'll adjust this volume a little bit more if it needs to, but I think it should be good enough now for people to be able to follow along at least, or to yeah hear what's being said. Yeah. So with this sort of a tech and analysis stuff, we're mostly trying to keep things, I
all right.
guess,
Would you
relatively.
like me to restart?
Okay. No, I think it's probably good now. Shouldn't be a problem. We'll like dig into things a little bit further. I'll bump that up maybe 5 dB more. Okay, I think you should have a relatively like similar volume to me now. Okay. So yeah, we like so yeah, trying to like do some tech analysis on different topics, and of course, yeah, things always like get a little bit off track, but we're trying to keep it sort of a little bit on topic maybe most of the time. So yeah, with the like V8 modifications, like yeah, I mean we've had over here also a lot of people asking about V8 versions of different engines, and yeah, there's of course a lot of details that people miss, like camshaft rotation directions and all kinds of yeah. As you, I think I read that you yeah, we're thinking about the chain tensioner stuff, like in which direction that protrudes from the engine and which sort of angle or which direction that ends up meaning for the cylinder head stuff. So yeah, lots of engineering things that go into that. So I was thinking about yeah, going through like the basics on what things are sort of important to take into consideration when you're doing a V8 version of a like an inline four engine in this case. So yeah, where to like start from, what kind of a different problems you run into. So these will of course be like generally applicable to different engine types also not just the K24. But yeah, we can get into some details on the K24 of course also. I mean, I'm assuming people will be very interested in that. Um, so yeah, how did you end up sort of deciding on a V8? Like there
Ah,
are
no
also
worries.
some projects on doing like a W type, so you have like three banks of four cylinders also, for instance. So where did like the V8 idea come from?
So, I didn't want to go the multiple banks uh, of cylinder route. I decided to try and keep that a little more restricted. But I did start with a flat 12 with was my first thing I was going to go with.
Okay.
And I decided to change my direction and go with a V8 as a more simpler and more approachable topic rather than going with the V12.
Okay. Yeah, I guess it is. Yeah. So are you like basing that at all on like any kind of like market size or interest
But
rate or
also,
anything like
sorry,
that?
we
Or
have a about 30 seconds, 15 seconds of lag.
oh, that okay. Yeah, I did notice that a little bit. Should we try reconnecting this Discord or something in case that helps? Because yeah, it gets a little bit difficult to yeah ask questions and and do that with a huge lag. It's really strange actually that we have that super long or super long lag. It shouldn't be that bad. Um, let's try reconnecting the Discord call to see if we can get our lag a little bit shorter.
I can hang up the call and then I can rejoin.
Yeah. Okay. Let's do that. Yeah. Okay. So yeah, we're having of course the stream is lagged a little bit, but we're doing a Discord call to get like the voices in sync, and that should be relatively like short delay. So we'll try this again. Hello. Is this any shorter of a lag at all?
Can you hear me now?
Yep. Can hear you. Volume seems to be the same. I think we still have
Yes.
a reasonably long lag here, though.
I can't hear you. All right. I think we're good.
Okay. So apparently we still have a really long lag here then.
Yeah, not the best.
Okay, so we do have some technical difficulties here, but we'll try
Other
to
sides of
see
the
what we
world,
can deal with this.
while also uploading to YouTube at the exact same time, isn't.
I have done like gaming at least with even more upload bandwidth in use, and yeah, it does seem to work relatively okay with like gaming with the people in the US also. So not sure what's happening, but yeah, some problems apparently. Okay, but I mean nothing we can do with that. We'll just have to try to deal with it. So yeah, I'll try to uh, ask some question, then I'll mute my mic and do some other talking, and then when you start to respond, I'll just shut up so that it works like well for the stream, I guess, or something like that. So yeah, try to do something like that. So or I'll try to do that. I'm not sure how well I'm going to to get that to work, but okay. So yeah, you said that you were thinking about a V12 also, but decided on going with a V8 initially at least, or was it even a Boxer 12? I have a 5-second memory, but okay. So yeah, with the V8, you do sort of. It's not like you're putting two inline fours together because you're, for instance, using just a single crankshaft, and the single crankshaft is one of the more heavier pieces which you of course save significant weight on by just having one crankshaft, even though of course you do need larger counterweights and yeah, and the bearing surfaces for the connecting rods need to be larger, of course, but there is space there. So what kind of a sort of weight saving compared to running two separate K24 engines have you been looking into? Okay, and muted myself, so we're just waiting for Craig's delay here to get online again.
Yeah,
Uh,
yeah. So right now, it's about. Uh, so for combining them, my engine block with the extra head is about 30 more pounds, so about 14 kilograms, I guess.
Okay, so that's yeah, actually not
And that
that
makes it so we're
much of a.
almost on track and having the two cylinder.
Okay, so this, yeah, we do seem to be losing some packets and stuff like that, unfortunately. But yeah, hopefully this internet, I mean, it does kind of work well enough. Okay, so yeah, it doesn't like, yeah, add that much extra weight to add a second cylinder bank row then from that. So power to weight ratio is definitely then going to be much better than with a single, like a traditional K24, just like a factory off the shelf engine block. So yeah, what kind of considerations like crankshaft design wise, and how does that like affect the connecting rods, and what kind of a bank offset you will need if you would yeah, go into a little bit details on that, please. So yeah, again, muting this to get the delay filled in here, and yeah, bank offset is one of the
Yeah,
important
sure.
parts.
You know, depending on your bank angle, it changes the different vibrations and the the primary aspect of your balance, whether it's first order imbalance or second degree vibrations. All of that comes into effect when you change your bank angle. And a natural bank angle for a V8 is 90 degrees, and that allows for some simplicity. I did look at a couple of different cylinder bank angles. I plan to go 75 degrees at one point, just narrow it down and make my overall package slightly smaller and a little bit more compact. But as it sits right now, my engine is just a touch smaller than a Coyote V8. That's the engine that's in the most recent Mustang. And so I felt like I was, splitting hairs and trying to get it to be just a little bit smaller and making it rougher and a lot more engineering technical difficulties in switching the bank angle to be 75 degrees and then having some other challenges associated with that. Right now it's 90 degrees. You can use any stock K24 head on either bank, just one facing forwards, one's facing back, and we'll go into the details of why I had that, I'm sure, in a little bit. But I'm
Okay.
all done. Over.
Okay, excellent. So yeah, the with the bank angle, so the firing order is of course something that will affect the bank angles you can use. So, see lots of people wanting to use like dual plane crankshafts, and that pretty much limits your bank angle to 90-degree offset if you don't want to use like split pin things or something like that. So this is something with if you're using a single plane crankshaft that is, yeah, then your bank angle is basically very like variable. But this also, yeah, of course, influences the vibration stuff. So well, it's second order vibrations mostly, I guess, and the firing sort of firing interval, of course, will change with bank angle or bank angle offset. So there is that trade-off, of course, also with V8 engine and package sizes, of course. So one of the really important things. But I think if I don't remember completely wrong, I think 8 cylinders with a typical four-stroke engine is like the least amount of cylinders where you can have a constant power output from the crankshaft. So even with six-cylinder engines and yeah, five-cylinder and lower, then you have like durations where the crankshaft output is negative, where you don't have a cylinder producing power. So that like kind of allows you, I guess, to use a little bit more tolerance in what kind of a bank angle offset you want to use there. I guess was this any kind of influence at all, or is this just? I mean, sound-wise, of course, even firing V8 is really good, and it of course like does help a little bit, I guess, on the longevity on the drivetrain components and stuff like this. So yeah, or is it just like, or yeah, what is the sort of thoughts going into like doing exactly 90 degrees? And yeah, muted myself again here. So yeah, this is actually packaging size versus sort of engine smoothness and firing interval
Uh,
evenness.
for me, it was uh, looking at I w- I wrote this whole like equation and calculator, and then did simulations of what the vibrations would be at different bank angles. And then I was like, okay, well, 75, if I made it 75, it gets this much shorter and this much and this tighter. And for me, it, it narrows the package by basically, uh, I want to say 2 inches, or roughly, almost 50 millimeters, I guess is what you would say. And that that while significant, still you still have the same engineering challenges of packaging uh, my engine the way it is currently. I have the intakes on the outside and the exhaust on the hot V, and so I felt like for me, it would make the difficulty of mounting uh, a turbo inside that valley more difficult by having that narrow 75 degrees. So I switched it back to 90 to give it a little bit more space for future turbocharging applications. And that's why I did that. So that way I have a little bit more flexibility. It is a touch wider, but at the end of the day, I don't feel like that'll be a problem with some of the vehicles that this will be going into. And that's kind of why I did that, and uh, and chose that. That's it.
Okay. Yeah, excellent stuff. Yeah, so have a sort of trade-off there on making it more compact and having sort of more flexibility for the future. And yeah, especially with the hot V with turbo, like leaving it open for turbocharging, I think is a really interesting uh, sort of um, parts of variables to sort of figure out and get that as optimal as possible. Of course, like engine bay wise, having a hot V is very good because that will typically mean that the turbocharger will be higher up, and yeah, you want to have the components that produce the most amount of heat as high up in the engine bay as possible, so that you can have components that don't want to be hot, like lower down in the engine bay, so you don't run into as much problems when you're idling in traffic or something like that, or other kind of scenarios. So you want to like use sort of natural sort of air travel due to heating as much as possible to take that to your advantage, I guess. So okay, really um, interesting thing there, and yeah, definitely, of course, to try to be able to fit some like larger turbo, which yeah, this type of engine would definitely need. So there's no point in running a 600 horsepower turbocharger on an engine that probably normally aspirated will do 600 horsepower already. So yeah, I need some space for activities in there in that V. Okay, so would you care to elaborate a little bit on the connecting rod selection there? So I'm from what I read in another interview you did, I think you mentioned that you'll be using a custom connecting rods there. So is that because the factory big end bearings are too wide to be able to fit two of those between one main bearing uh, like opening there, or was there like some other process here that you needed to get different bearings or something like that for this, or is it just to like basically make the two connecting rods fit, or what was the main problem there? Yeah, so this is so you do have significant allowances with like
Excellent question.
oh,
The reason why I did it the way I did, oh, sorry. But the reason why I did it the way I did was because the main bearing to rod journal bearing overlap on the K24. Uh, the K24 has a really long stroke of 99 millimeters, and the bearing overlap is only uh, 8 millimeters squared of area. So super tiny amount of bearing overlap. And while that's totally fine for most four cylinders, but for V8, uh, that that's a little small. So I had to up the actual sizes of my bearings in order to get a little bit more overlap. So that way I could strengthen my crankshaft in order for it to be, I would have been totally fine if I was running just pure NA all day, naturally aspirated. But I want this engine to be able to survive under boost and to be able to be a boosted application. So I needed to get some strength back into my crankshaft because I took basically a regular standard K24 crankshaft, and in the space where I had to fit only just one connecting rod, I now have to fit two. So in order to make up for chopping that width out of each crank arm, I upped the bearing size. So I'm actually going with Lamborghini Gallardo main bearings, and then for the rod journals, I'm going with Honda J35 uh, rod journals, and so that increases that main bearing overlap area from just that puny 8 millimeters square to over 375 millimeters. So you get this much stiffer, much more torsionally strong, and a much beefier crankshaft that can handle a lot more power output through it without my my fear of it snapping or being potentially underloaded. For perspective, an LS1, sorry, an LS2 has uh, around 200 millimeters of uh, cross-sectional area between main bearing and rod journal, and then a Coyote V8 has around 375, I believe, as well, millimeters of cross-sectional area as well. So I'm right in there in the thick of it as far as bearing overlap and all that. So that's kind of why I ended up with having to go with slightly custom rods. Rods are actually still the same thickness as a regular K20 for 19.85 millimeters, or that's what I ended up sticking with. But they are set up for a much larger bearing than the K24, which I believe is 55 millimeters, and I think the J35 is 65 millimeters. But I'm not 100%. I'll have the spec sheet right in front of me, and I'm not looking at cats, so don't quote me on that. But that's kind of the reason why I ended up having to make those adjustments and those changes in order to get the strength of the crankshaft.
Okay, really interesting stuff there. So that's yeah, one of the things, for instance, on our Thor engine and Rex engines that, to be honest, I don't even look at those values. It is like a really sort of a very good comparison value between engines, because you really want the sort of stiffness to a mass ratio to be as good as possible, because that dictates your natural frequencies and stuff like that. But to be honest, like, I skip all of that and just do FEM simulations on the crankshaft to check the natural frequencies. I guess, yeah, it's more like a involved sort of slower way, I guess, to do the same thing basically. But yeah, I mean, I for instance couldn't give you the values because I have no clue. We've never even calculated those for our engines. But yeah, I guess that's a much more efficient way to design crankshaft, because it is a really important factor on the torsional rigidity, to have the, yeah, overlap section there, or the yeah, sort of when you look down the end of the crankshaft on how much the bearing surfaces sort of overlap each other. So yeah, interesting stuff to see sort of yeah, different approaches to basically looking at the same problem. Okay, and so another thing people probably don't realize is how much sort of uh, thought goes into the valve train components and the camshaft drive. So probably like would assume that lots of people naively think that you can just like put two cylinder heads like just attach them beside each other and you can put them whichever way you want, and there is not going to cause any problems at all. And yeah, so first of all, like having two like identical cylinder heads on a V engine with like the exhausts pointing together or away from each other, that means that one of these cylinder heads has to be the like opposite way around. This, of course, means that if you just drive it directly, both ends directly off the crankshaft, then the camshafts are going to be spinning in opposite direction on one cylinder head. And yeah, you have a solution, of course, for this on the K24 you're designing here with sort of a idler pulley there to change that rotation direction of the camshaft for the reversed heads. But could you go into a little bit detail about what the sort of goes into the valve train components, so how the cam profile affects the situation and how the rocker geometry. I'm not even sure. I'm assuming the K24 does have some kind of a rocker or finger follower or something like that. That for the lift profile there, and well, of course, yeah. Then you have the probably adjustable cam timing, I would guess also. So yeah, could you explain sort of the basic technology behind that, please? And yeah, muting myself again. So this is yeah one of the actual more complicated things that is
Yeah,
very
no
important to take into
problem.
consideration.
So basically, yeah, as you said, I had to add an idler gear to drive this rear uh, facing cylinder head. And for me, the main hiccup was the location of that gear on the crankshaft. If you look at some of my early Instagram stuff, I have some pictures of crankshafts, and I have this deep cutout, and then a gear, and then I ended up putting the gear on flywheel mating surface, and it moved around a whole bunch. And I actually thought about splitting up the crankshaft into two different uh, segments and kind of go with like the BMW route. And um, because the BMW, I believe it's S58, has a split crankshaft where uh, it has the hub and it has the chain drive for the gear and all that, and go that direction, because some of the price quotes I was getting for the crankshaft were just astronomical. But I found a company actually in the UK called Aero Precision, and they were able to work with me, and we were able to come to a solution that works for both of us. We had to play around with the module of the gear and its pitch diameter and like its particular location to make it more machinable and better. So that's how it ended up where it is. And then for the valve train and all that, the Honda K24 has a couple of different things associated with its valve train. Hondas are most famous for VTEC, and that's a variable lift, or the valve at a certain point in the RPM range, it'll lift or push down farther on the valve and allow more air into the cylinders. That has a distinctive sound. Uh, there's jokes about how the VTEC grow and having that kick in, wait till the VTEC kicks in. But so you have variable lift on the camshafts, and that's on there. But there's also variable adjustment of the phase of the actual camshaft. And on the K24, that's on the intake side of the camshaft, and that's one of the things that is adjustable and can be controlled as well. And it does a finger follower cam uh, system, so the cam hits those fingers, which then pushes down on the actual valves itself. Very simple design, very sturdy and reliable system. I've had to mess with that pretty much like at all. I can use stock heads on either side of my engine. For me, the thing that I had to modify a whole bunch was the timing chain guides and the location of the timing chain tension. That's it.
Okay, yeah, good stuff. So yeah, there's of course always the possibility of just running one of the camshafts sort of in reverse direction, but that means that you need custom camshafts basically because you need to compensate for all the geometry that you're running the opposite direction, and then you don't have the freedom of using different camshafts for different users or whatever because they need to be specially made for the sort of a cylinder on the wrong side. So yeah, then apparently you decided on the yeah, optimum solution being instead to just reverse the direction of the cam drive so that you can run like absolutely identical parts on both sides. So yeah, definitely makes very good sense and good design for that part. Wondering what else are there like important things with these sort of custom V8 engines. I think there are some motorcycle-based engines I think that I've seen that have sort of chain drives down the middle that also use bucket lifters. So those, of course, well, you still can't run. Um, well, it depends a little bit on the cam profile because there are like still some cam profiles that are symmetrical. I think most profiles will be non-symmetrical now. So you yeah use the opening ramp and the closing ramp is just dictated by the valve spring stiffness. But the sort of actual geometry for the valve opening mechanism is symmetrical. So if you have bucket lifters, then you can run the camshaft in either direction without a problem. So that is yeah definitely helpful if you have a engine system that uses that. But I don't think there are any modern engines that use that type of a setup anymore. I think they've yeah all sort of gone to the wayside by now. Um, okay, but yeah, is there? Mm, yeah, maybe something left about the sort of like basic tech stuff behind doing a V8 version that we've missed here so far, or that I haven't come to a thought of asking. Like, is there any like major packaging thing or build wise? I think you mentioned something about the oil ducting, so I would assume that's typically not going to be a big problem. But has that actually like turned into being like a real problem in the engine that okay it actually needs to be a hot V because otherwise the oil feed system like to be compatible with the factory heads would be really difficult, or is that sort of a secondary issue mostly, or yeah. So yeah, this is oil feed stuff typically will not be super difficult, but there might be some instances where it
So
would be.
great question. It it did turn into be a little bit of an unexpected hiccup. So I modeled block, I modeled oil return galleries, and then I started working on the I modeled the main bearing oil flow, and then I was like, okay, now it's time to throw in the tensioner. Let's stick that in, and I was like, oh, okay, well, it's right at the split line of the girdle between the girdle and the main block. That's not ideal. And my routing of the oil to get to that spot goes across both of the main studs and has to like weave around the head bolts as well because I kind of my cylinder heads are offset and a little weird. So the cylinder that's facing forward is actually on the back piston uh, on the back connecting rod. So it's pushed either way, offset either direction by like 20 millimeters. So it's a little weird. It allows me to maximize my space even more, but it makes the oiling location for this tensioner almost in the same plane and area as my main studs. And so uh, when the day I found that out, I about cried. I was like, okay, how am I gonna make this work? Because I can't like just carve out a section and remote oil this. So what do I do? And so then I was actually looking at my wife's car at the time. She was driving Mercedes C63 AMG W205, and that's a hot V. I was like, well, I could make it a hot V, and then it was like, okay, I can make it a hot V, and then the tensioner went from this horrible, how am I going to make this work, to, oh, you just drill a 6 millimeter hole right here and no problem. And you just have a pocket for the oil and it goes and it's not an issue. I could have gone with a purely mechanical tensioner system. I wanted to keep this as close to stock Honda as possible. So that way people always know, oh, if I have a problem with my tensioner, I just get another stock Honda tensioner. And so that was a little bit of a challenge. I do have a dry sump system, and when you're designing an engine that's custom, um, I think you feel the same way as I do. You should have your oil passages not like intersect and go into you know, the where the whole crankshaft's going to be spinning and all that. And you should just keep those oil return areas separate and have them go straight to the dry sump and not intersect. So that way you can keep your windage down and not have any issues with that. And I think some people don't always do that with their dry sump systems. And so for me, planning dry sump from the very beginning, that simplified oil input in, so that way I don't have to have like an oil filter that screws on housings, because this is a flat engine, sorry, a flat plane engine, and so it has a lot more vibrations. In my main car, my daily driver, it's a Mustang, it's a Shelby GT350, and that also has a flat plane V8, and they did not think about the vibrations of that engine very well, and I've had my oil filter come loose on that car twice and leave me without a whole bunch of oil twice, and that was a little scary, and having to fill that back up, tighten it, and even though I'm torquing it to the correct spec, 2 years later after my car, they switched the oil filter design to be something separate, a cartridge style that's not as susceptible as vibrations. So for me, dry sump and hot V were critical, and um, the water pump system on the K24 is a little complicated. It's mounted off of the block, and it's really big, bulky. I was just like, nope, and I skipped that, and I decided I'm going electric, and that simplified everything. Like I just have a 16 AN fitting in the block, and then it comes out the head, and I just route those radiator, and it's a lot simpler, easy setup. But those were like the two big hiccups and challenges.
Okay, that's yeah, really interesting sort of layout. I didn't actually, yeah, think of the like the orientation of the cylinder heads and how the offset is. You can actually like overlap that, so that probably like reduces maybe 40 millimeters from the length of the engine or something, because you can have the sort of the cylinder head with the forward-facing cam drive running on sort of a back connecting rod on the crank journal there. So that, yeah, that saves you a lot of compactness there. And yeah, really interesting solutions there. So yeah, you can manage to have all of the oil sort of feed parts inside the V then. So okay, that simplifies the oiling system a lot. And okay, so we did touch there on the uh, crankcase and the bottom section there. This is actually a good question that, or a good like area to maybe discuss a little bit more on also. So at least what I've looked at designing, so like doing a traditional wet sump system is, I mean, for like normal street use, that is of course absolutely fine, and you have millions and millions and millions of cars running that all the time without any kind of issues at all. Uh, but to design something like that that works for high performance use is, in my opinion, incredibly difficult. I mean, it is doable, but it takes so much time to do. And if you're already like doing a custom solution where you might want to do a dry sump system anyway, then I think it's just so much easier to design an engine for dry sump use from the beginning, because then you could just like keep each crank section separate and have like a not exhaust ducting, but what is it, like extraction ducting for the oiling separate for each of those pieces. And I see that that is a much like easier way to, I mean, it saves so much design time, and it is like a better design overall also. So there was like no downside on that, except you need to run a dry sump pump, of course. But then again, you don't need to have the oil pump, so you'd still need only one oil pump drive system anyway. So definitely, I think a big advantage of just yeah, if you're designing something from scratch, then fully design it to be dry sump use, and not do these. You see like lots of conversion things from wet sump systems that are just really bad. Like, oh, here are people wanting to design that you have like this really wide section there so that the oil will flow down efficiently into the bottom of the sump, where your dry sump system can then like extract the oil, and it's like, no, that's definitely not a very good idea. So yeah, super enthusiastic or enthused to hear that. Yeah, someone else has also come to the same conclusion that just running a full dry sump system and having that like separate is a better solution. So really interested on that. But I would want to ask you a little bit about the crankcase there. So you have the block split at the crankshaft. I'm assuming the K24 actually might have that. It is a kind of moderate engine, so it probably has that design to start with. Of course, with the V engine, the split plane is at a it's completely separate angle, so it has nothing to do with the factory block. But how is the sort of
It is.
design-wise the bottom section there? Like how much sort of effort would that be like compared to running some kind of a like old like cast iron V8 thing where you have like the block go all the way down, then you just have like a sump underneath where you have the crankshaft like completely sunk into the whole block. So do you have any like insights on that design wise? So yeah, this is also, I mean, there are always multiple solutions to a problem, but like what is the most efficient way to solve it is yeah, a big question sometimes.
Uh, yeah. So for me, I looked at some of my favorite engines. The Honda K24 is a split girdle design where it's split right at the crankshaft. And then I also looked at like engines like the Mitsubishi 4G63. That engine has like a little girdle system that you screw onto the main caps afterwards, and that stiffens up the block. Um, and I'm an American, and so like my first car was a muscle car, and so I was used to just a regular 2-bolt main cap design, and that's totally fine, and you can make that work. But I wanted the stiffest possible solution I could make and the most robust, and that I don't have any excuses for why this engine block couldn't handle X amount of power or Y amount of power. So I went with this direction of being split at the girdle and having, instead of being like the Honda K24, those stock blocks with sleeves can handle 1,000 horsepower. So I felt like going down that direction would be like a good way to go. But I thickened it up and I beefed it up. So the lower girdle of my engine is actually made out of a different material. So the top half is 6061, bottom half is 7075. so a higher grade of aluminum. Uh, and instead of having 2 bolts, I have 4 bolts, and I have uh, head studs from a BMW, and I'm actually using like studs from like a Suzuki and oh, sorry, I actually mixed that up. I'm using BMW S65 head studs as well on my main studs, and my main studs are not regular Honda studs, but they're actually Mitsubishi studs that are even longer, so that way I could get into the main meat of the block to keep the stiffness as much as possible and make it a really robust package. So I have 4 bolt mains across all of them, and it's a complete girdle assembly, so it's extra stiff. Really, really, really happy with that. And I was also able to carve out a lot of material from that area and get it to be a very light component. So it, my block is, only, around 14 kilos heavier than a regular stock K series block, even though I have this whole extra head and a whole much beefier and thicker system to hold it all together. But that basically covers that.
Okay. Um, yeah, interesting stuff. So probably, yeah, design-wise, sort of, yeah, comparing that a little bit to other type designs, and yeah, going for the stiffest possible solution, I think is definitely a good idea because it saves sort of on potential headaches. I mean, it's sometimes difficult to know exactly like how stiff is stiff enough, but yeah, I mean, pretty much the stiffer you go, the better it is. So there's no real like direct downside to making it stiffer. So it's yeah, easy solution really for that then. And yeah, interesting to see that yeah, what kind of hardware components and stuff like that goes into this. But okay, I don't think I have too much more to inquire about you about this engine. I think we did most of the sort of things that go or like that are different in a V8 version of an engine compared to just like a inline four and how those components sort of differ and what the sort of main aspects of those are. So yeah, thank you very much for joining in on this, and yeah, I'll yeah hand the talking over to you for a short while if you have anything that you want to finish off here with, or some like highlight points or anything like that you want to go through. Yeah, definitely need to work on my interviewing skills here a little bit, but let's see.
I just wanted to thank you for allowing me. uh, it's good. You're doing a great job, and I'm no professional either. Um, I did see that somebody commented asking about the sleeves, if they were the regular standard K series from Darton, and actually they're not. I chatted with Darton very early into my design process. I was like, "Hey, I'm uh, on a regular K series. You have this huge like crankshaft tunnel, and you have lots of room. But on a V8, you don't have as much room, and my uh, connecting rods were hitting the second cylinder, and so I have to notch the lower section of my sleeves. And I was talking to Darton and whether that'd be okay, how much I could go, and they actually recommended that I use a different sleeve than what was for the regular Honda series. Sorry, than what was for the regular K series. They recommended that I go with the sleeve that's actually for the Honda S2000, the F20 sleeve, and so that's what's actually in my engine. Um, it has more area for me to be able to carve out slightly stronger and a little bit more robust sleeve than the actual regular K series actually put with that. Um, Overall, I'm hoping for this engine. Uh, to hit around 750 to 800 horsepower naturally aspirated, and then boost. We'll see. I think the crankshaft will be the main sticking point, and whether I've made it strong enough and whether it's robust enough. You mentioned a little bit about the FBA and doing those simulations, and run lots and lots of simulations. Everything says it should be really strong, but theory and reality can often be very different. Um, and so we'll see about that. But hopefully, I would like to be comparable to what a stock K series can handle with the sleeve, and that's 1,000 horsepower. So being able to hit 2,000 horsepower out of this engine would be ideal, and that's what I'm hoping for. But we'll see. I have to do a lot of engineering tests and creep up to that number, and rip apart, check main bearings, make sure I'm not having any issues, make sure everything's all running well up into the RPM target I'm shooting for. My RPM target is actually kind of high. I'm shooting for over 10,000. I would like to be at least at 10.5 with my naturally aspirated build, my turbo build. Unless I'm running aluminum rods, that'll be a little bit more RPM limited just due to weight and second order vibrations. But I do want to thank Darton. They were a huge help. This MID sleeve allows me to simplify the block design and just have these sleeves just drop in and be present. I have to have really nice machine tolerances, but they work really well, and they can be a really robust system and allow for a simpler engine design process. I'm not trying to hit 3,000 horsepower or anything like that. And if I was, I would go with like completely dry system, and I would go that direction. Or if I was trying to make this be a little bit stiffer, I would have material in the actual center and then have crescent sleeves. But with the Honda, your bore is the bore spacing is only 94 millimeters. I don't have as much room to play with it. If it was 100 millimeters, I'd definitely do that, and I'd have dry Preston, iron sleeves. But I don't have as much room, so I have to kind of do a slightly different design, but still have enough strength to be able to hit those horsepower numbers. Maybe I'll be able to go higher, but we'll see. I'm not going to be competing with you guys and what you have on your Thor and Rex engines.
Yeah, that is
I
definitely
think that basically covers it from me. Unless you have any other questions, I'm happy to answer.
okay. Sure. Yeah. Just maybe some final remarks, maybe on the rigidity and stuff like that. So, yeah, I did mention uh, the sort of Siamese or MID type sleeves and how that sort of ends up making the block a little bit softer. Of course, with a V8 engine, you have so much more cross-sectional area there that you don't need like that much rigidity from like the cylinder bank itself, because you just have so much more torsional rigidity from the block like overall cross-section area there. So okay, that's actually interesting that you've more or less concluded the sort of same stuff really. So yeah, and so you've apparently done some estimates on that, or ballpark figures at least, that you think you can probably run 2,000 horsepower with this. But if you want to go like more than that, then you would need to run drive sleeves to have the blocks sort of remain more rigid, which is, yeah, it's actually like a really interesting topic by itself. Also, it's getting a little bit maybe off topic now, but one of the really interesting things that I sort of look at it with the MID like installation instructions, for instance, from Darton. Like, yeah, when you install these on a sort of, I'm assuming like drag racing type V8 engine or something like that, where you typically like do MID sleeves. I don't think you would do that on a stock engine or anything like that. So So on these like racing engines where you can have like the engine block basically twist and like deform a little bit. So it's like, okay, yeah, it's normal to have like up to some sort of, I think it was like 0.5 degrees or something like that of like twist in the engine block, and then it's still like okay to use, and you can just like put in new MID sleeves and run that. So then I think you're starting to get sort of at the sort of a limit of how flexible that can be. So it's yeah, really interesting that that's something that you've taken into consideration also, and yeah, really interesting to hear that yeah have enthusiastic guys that are really looking into all of the details, not just like slapping stuff together and calling it a day basically, but really going in deep in all of the details and figuring out all these different components. And also interesting because I mean a lot of the stuff that we design here are just like ballpark figure things, and because yeah, I mean there are so many different details that you can look into and calculate and stuff, and it just like ends up at some point you just have to call it a day, like okay, we want to spend time on these aspects because these are important, and these aspects we just want to ballpark because they probably should work just like doing things relatively quickly. So very yeah, interesting to hear that sort of like strength or like stiffness wise ballpark things that we've been looking at, like the running dry sleeves, for instance, to have the torsional rigidity. That sort of the similar ballpark figures are basically what you're looking at using also for the V8 versions. Or it doesn't compare, of course, similar like directly, but sort of like ballpark figures on when you need to start really thinking about rigidity is yeah, like similar ballpark areas. So really good to hear about that. Oh, and a sort of side note also, I think I figured out now why we have a huge delay. So I'm assuming that you're listening to my audio from the YouTube stream and not via Discord.
I am, because it's not coming through on Discord, the audio, and so that might be a hiccup on my side.
Okay, well, good to notice that now at the end of this. Yeah, I'm not so good at this figuring out stuff what to do here. Um, but okay, it's stuff to learn for next potential interview stuff. But yeah, you seem really sort of technically interested in all kinds of engine stuff. We'll see if there's like maybe some interesting topics at some yeah, future things or something like that, and yeah, maybe you could do some future interview. And yeah, you did also mention, so yeah, we discussed stuff on Instagram a little bit, and yeah, if we can think about stuff. I mean, of course, after this stream, but think about yeah, doing yeah, maybe some Thor or Rex discussions or something like that. And if there are some like details that we can maybe discuss that could potentially like help you or anything like that. So we'll definitely be interested in doing that. And if that is something that might like be interesting enough, then yeah, we could maybe think about doing some stream for that also. So that would yeah, potentially benefit other people also that are looking at doing yeah, custom engine stuff and these kind of things. So yeah, but thanks a lot for stopping by. I guess we'll sign off for now. I think probably we'll wrap out off this stream maybe 10-15 minutes going through some small details, and yeah, I can message you later and we can see about the Rex and Thor stuff and what kind of a time frame we would have about yeah, looking at some details that you maybe were interested in asking or talking about also.
I would love that, and I appreciate it, and thank you for having me.
Okay, thanks, super, and yeah. So excellent stuff. That was Craig Williams from, oh, I'm horrible at remembering things. So yeah, Craig Williams, Neutron Engines, working on the V8 version of the K24 engine. And yeah, you always like hear so many different, like, yeah, we're just doing a V8 engine of whatever, but this actually did seem yeah, relatively well thought through. Looked at some quick stuff about that, and yeah, I mean, definitely. I mean, this guy knows what he's talking about, and yeah, it also like kind of different about knowing what you're talking about and looking into things and figuring things out. And yeah, I have no doubt at all that they're going to be able to make absolutely yeah well-functioning system like this, and yeah, will probably be like a really enticing price point for a lot of people. So yeah, it will be exciting to see what happens with the K24 project and yeah, the V8 version of that. So yeah, definitely good stuff. Let's check chat here a little bit. Yeah, I did check this, but it's a little bit difficult with a huge sort of a time delay to yeah do the chat messages in between. Also, it gets a little bit complicated. So yeah, we get a TRX complicated that yeah most 70s, 80s, and 90s Japanese motorcycles. Yeah, so these will have the typically have like a chain drive, and yeah, we'll have so yeah, these like old time frame things will probably have symmetrical camshafts, so you could probably run it like either way, and the lobes will work perfectly. So then you can run a V8 version just with like flipping the cylinder head over the other way and just running the camshafts off the same drive. Basically, you just need to time them correctly, and it should probably be possible to do that without having to reverse the rotation direction and all this kind of stuff that you need to do on sort of a more modern engine that they're doing on this K24 here. So the sleeves in the VA the same as the regular casers. Okay, yeah. So this was yeah already answered here, so I don't need to go through that. So the sleeves, yeah, we actually yeah did go through that a little bit later also on the sort of how that influences the stiffness. So in case yeah, you guys are not familiar, then this is also one topic that is super important, like how stiff the overall engine package is, like as a package and compared to each other. So typically a cylinder head will be relatively um, like not very tall, so it will have like a relatively like low sort of stiffness. What should I say in the sort of torsional torsional direct, like for torsional twist, basically. And so that will allow it to move a little bit, which is kind of good because it allows it to conform to the block if the block flexes a little bit. But if you end up running sort of these MID type sleeves, they reduce the torsional rigidity on your engine a lot. So if you have like an inline 4, then that will make the engine much softer is the wrong word, so that would but like more flexible, and this might well typically at some point will start creating big head gasket sealing problems. And yeah, so one thing that you can do is like optimize the parts to be like flexible in relation to each other, so you have a similar stiffness or effective stiffness between the different parts. So with a V8 engine, yeah, will typically like flex around the sort of probably a little bit above the crankshaft area will probably be the sort of a center of stiffness, or actually the bottom section. Yeah, I'm not really sure where the sort of a center of flex will be. Maybe, but probably somewhere around the crankshaft area anyway. And you will start like building up like torsional flex there. But this of course requires like huge power load. So you're talking about serious drag racing engines, stuff like this, until before you start running into that kind of problems. But yeah, then like having a head that is more flexible might actually help you seal the head gasket better in that case, and yeah, optimizing things to be able to sort of focus. So typically what you see also on head gasket things is yeah, focusing the clamp loading around the cylinder to be able to clamp that better. And yeah, this is something that we don't do on the Thor engine. For instance, we design because we designed the cylinder head and the block, then we design those together to distribute the clamping forces without having like stepped head gasket or stuff like this that are typically done. And yeah, then optimizing the sort of stiffness overall of the package is something that is relatively important if you really want to push things as far as they will go. But yeah, I think that they definitely have taken this into consideration here on on their K24, and yeah, probably will get that to work absolutely fine up to, yeah, what they were estimating, 2,000 horsepower, probably definitely doable, because yeah, if you can do 1,000 horsepower on a four-cylinder K24, then a V8 will sort of relatively wise be stiffer in comparison. So I don't think there would be any problem doing 2,000 horsepower if a single bank can do 1,000 horsepower with these MID type sleeves. So definitely doable to use that. Getting a little bit off topic here, but John Newman, thank you for the stream. Yeah, thank you so much, John Newman, for stopping by again. I mean, this was so on the previous streams we've had sort of more interaction, but now yeah, we had a live guest, so the sort of interaction with the stream suffers a little bit, especially because yeah, we unfortunately had a big audio delay here with the stream stuff. So and yeah, couldn't understand what the problem was there, so just figure that out right at the end there. That okay, so he's actually having to listen to the stream via YouTube, and that has a long delay, so that ends up yeah making the stream not as interactive as it could be. But I think we got that to work there at the end. But yeah, thanks so much for stopping by, and yeah, you guys are of course really what makes this happen, and yeah, so thanks for stopping by. Harley V8 Hayabusa has a reversing gear on one bank, so all cams rotated the right way. Yeah. Okay, yeah, so Wicked TRX, thanks for that comment. And yeah, apparently so this is a normal solution to be able to run this type of head setup. Yeah, like they have on this K24 also. So as a quick disclaimer that also, yeah, like off stream I mentioned to Craig here that we have been planning on running or making a smaller V8 engine. So basically that would be power-wise around the same as our Rex engine, but much smaller and lighter weight. That would also be very much cheaper. And on that engine, we actually pretty much decided that for what we wanted to do, it would be cheaper and sort of simpler overall for us to just make a custom cylinder head instead of yeah, flipping the factory cylinder head around and having the gear drive off of the back end, designing the gear drive system for that. So it depends on yeah what type of a setup you do and what is easier and in which conditions. So typically, I mean, the cylinder head is definitely one of the more expensive parts to do, like setup-wise forecasting. I mean, once you have everything set up, then punching out like cast cylinder heads is not too expensive. But yeah, I mean, doing just a one-off like a billet cylinder head design for a typical engine, I would assume that we're probably one of the better companies here at Elmer Racing, or maybe the sort of most efficient company to be able to pull that off. So for us, for that engine design, it's like easier for us to just make a cylinder head that is designed to run the correct way around, so to say, from the beginning. So then we don't need to have this pulley gear to reverse the rotation for the second cylinder head, basically. So I mean, but yeah, I mean, there are multiple different ways to do solutions for stuff, and if you need to make things incredibly cheap or like as cost effective as possible, or whatever you want to call that, then yeah, running factory cylinder heads or having like full factory head cylinder head compatibility, like for a platform where there are multiple different cylinder heads already available, then yeah, doing this type of a solution on the K24 here, or the yeah, the Hartley V8 Hayabusa engine, yeah, I mean, definitely makes sense. So yeah, there are always like multiple ways to solve things, and yeah, different solutions will have a different optimum sort of yeah, optimum ways to do the solutions depending on yeah, not only like just the basic physics, but what kind of skills you have like in-house also, and all kinds of details. So yeah, but I think we covered sort of most of the basics on V8 engines. So yeah, the valve train component geometry, so both the actual like lift profile you want to achieve, and then we didn't actually touch on that, I guess, a little bit, but yeah, so having a rocker geometry also, that also like makes the load profile non-symmetrical, because you will have a different rocker ratio on the opening than on the closing section of the cam lobe. So that needs to be taken into consideration on the cam lobe profile. So you can't just run a cam lobe that is designed to run a rocker or like a finger type follower. You can't just run that like in reverse direction because the acceleration profile will be completely wrong. I mean, on some engines you might be able to get away with it, but it will definitely like affect the VE, so you would have like different volumetric efficiency on your right and left bank basically, because your profiles will be way off and you will have a higher like loading and wear on components on one bank compared to the other bank. So yeah, it is definitely something that needs to be like reversed or fixed or taken into consideration somehow. Okay, but I think that's more or less it for this stream. And yeah, thanks to the yeah, you guys over the stream for stopping by. And yeah, this was not as much of a interactive one maybe this week as usual. No problem with this bucket system, but most part, yeah, that's true. So yeah, with the bucket system, you have a symmetrical like interaction, but then of course if you want to have a non-symmetrical like lift profile, we did go through this at the when we talked about this in the stream, but to recap that a little bit, so there's like two separate things. So what kind of a valve lift profile you want to have, if that profile is symmetrical or not, and then how the mechanical like lift system interacts with that. So that can be symmetrical or non-symmetrical. With a bucket lifter, that geometry is symmetrical, so then it's only a question of if your valve lift profile is symmetrical. Typically these will not be symmetrical. So even if you're running bucket lifters, that doesn't necessarily mean that you can run the camshaft in reverse if the lift profile you have done on that camshaft is not symmetrical also. But on like older type engines, on like 70s, 80s, 90s Japanese motorcycles, then that typically will be the case. So those you can reverse. Okay, but that was it for this stream on V8 engines and what kind of details to take into consideration when you're doing like a V8 version of a sort of existing four-cylinder engine. And yeah, hopefully this helps people and helps explain to some guys why you can't like just slap on parts and like yeah, this is just like two inline four engines. There's a lot more that goes into this than that guys. So yeah, hopefully this helps someone. And yeah, thanks for stopping by, and we'll hopefully see you guys if we do another episode. So yeah, thank you and goodbye.